Hey everybody, I'm just making a video kind of just going over some of the basic concepts for um, having a terminal arm swinging around in different quadrants, just because some people asked me to post one. So just a reminder in terms of like kind of the new thing. So like if I have a grid, right, the main thing now is that what I'm doing is I am doing trigonometry on the XY axis. Okay, so this, I mean, sometimes I call this like the XY axis. Sometimes we call it the XY plane. Plane is just a fancy word for like a two-dimensional piece of paper. Okay, so just a reminder of the initial kind of definitions. Okay, so say I have an arm that has this vertex at the origin and is just lying on the positive x-axis. Okay, so this here we call the initial arm. Okay, so what happens is that we want to now spin this arm around the x-axis, and how many times can it spin? Well, it can spin forever if we wanted to really talk about it. So if I'm going to have now some point here, and I'll just call it a general point P X, Y, okay? So this point is now on the terminal arm. So say this initial arm swings, and it swings to here, okay? So this angle we call theta, all right? So now we know in this quadrant, theta is between 0 degrees and 90, okay? And then where does the trig component come into it? Well, what we do is we say, okay, well, I can really make a perpendicular triangle anywhere here as long as I, from a point, drop a height or a perpendicular, okay? So now, let me just move this out of the way. In terms of labeling the sides, well, now I know. So for example, what is the value of this side and what is the value of this side? Okay, well, if this is a coordinate xy, then like I know the distance, like this coordinate here is x. And what's this coordinate up here? That's y. So that means this whole distance here is y. This whole distance here, right? Oh, shoot, sorry. Sorry, that's kind of annoying. That is x, okay? So now remember, what did we call these before? Before, these were called, right? Like if I label this side, so from this angle, right? From angle theta, right? This we call the opposite side. This we call the adjacent side. Okay, now this we call the hypotenuse, right? Now, because we're on a coordinate system, right? The XY plane or the XY grid, I'm going to give the values for the adjacent and opposite and the hypotenuse. I'm going to give them like their coordinates, right? Because that's going to tell us where we are on the XY grid. So we have X here, we have Y here. Now this, we call the hypotenuse. Now the reason, like, so we're not going to call this H, we call this R. Now why do we call it R? Well, because if I were to spin my terminal arm all the way around the X, right, what do I have? I get a circle, right? So here, right, my R, which is the radius, oops, sorry, oops, there we go. Sorry, just ignore that. My magical pen has a weird button that I accidentally keep pressing. So my radius right? This used to be my hypotenuse, right? The x used to be, or sorry, is what we call the adjacent, and the y is what we call the opposite, okay? So now, in terms of doing our trig ratios, right? So now here, right, sine of theta, before I wrote opposite over hypotenuse, right? But now, because I'm on a coordinate system, like O doesn't make any sense. What is O, or what is the opposite? Well, the opposite is the y value. So I'm going to write y over, and the hypotenuse is now r. Okay. Cos of theta is adjacent over hypotenuse, but again, adjacent over hypotenuse doesn't make any sense on the coordinate system. So we need to make sense of it by writing x for my adjacent and then r for my hypotenuse. And then the same thing for tan. Tan theta equals, well, that was just opposite over adjacent. Well, opposite now is the y value, and the adjacent, well, that is just x. So now, these are the new ways that we're going to write out the trig ratios. So I'm essentially going to ignore these ones now. Okay, because we're now spinning around on the xy plane. Okay. So now the beauty of this design is that I can adapt these ratios in any section of the xy plane. So let's do one. Let's see what happens next. So if I'm not going to spin into another quadrant, right? So say my point on a terminal arm is here. So P. Now notice I'm labeling the x as negative. Why? Well, because see how now I exist on the negative x-axis. All right. So if I draw my terminal arm here, I'll draw my theta nicely. Okay. And then again, I'm going to drop a height. Okay. And then now, well, this side is labeled y, right? Because that's the y, positive y-axis. Now this is going to be negative x. Now this, what's r? Well, r is still going to be r. Okay. The radius here, this r will never be positive or negative. Why is that? Well, what's the formula I use to find the hypotenuse, right? It's essentially that. So like if x is negative, right, say I want to figure out what a negative x is going to be, say it was like -2. What happens to that negative? It automatically becomes positive. So my r is always going to be positive, okay? So again, these numbers here that I chose, I literally just made up the -2 and 3, okay? So let's group this. I'll just shrink it, okay? So now, one other thing I guess we can talk about. So every angle swing that's over 90, like I have this value for beta. So beta is what we call the related acute angle. So every swing, whether it's in quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4, every swing of theta past 90 will have a related acute angle associated to it. And that's going to be important because that's like, if you haven't noticed, like this triangle, even though it exists in the second quadrant, I'm using the related acute angle to make this related acute triangle to then come up with my trig ratios. Okay. So here, so just like we did before, well, if I want the ratio, so sine theta, well, I'm in this quadrant, well, what's sine? Sine is opposite over hypotenuse, or y over r. Cos of theta, that's adjacent over hypotenuse. So notice how cos now is negative because the x is negative. And then tan of theta is y over negative x. So when I look at these values now, right, these are my ratios for sine, cos, and tan in the second quadrant. Now let's just compare these values to the ones here, okay? So notice, like, the letters are all the same, right? The only difference is the negative. So, like, notice here, cos is positive, tan is positive. All of my ratios in quadrant 1, right, this one up here, are positive. So the only difference when I'm in quadrant 2, right, cos and tan are negative. So this is where we start to talk about the Cast rule, where in this section, sine is positive, right? In this section, all of them are positive. Okay? Everybody cool with that? And then I can keep doing that as I swing around the xy plane. Okay, so if you feel like you get it, then I mean you can literally mute me if you haven't, shut off this video already. But if you still want to see, so say I swing into the third quadrant. So again, I'm going to have some point here, P. So notice x is negative, but now y is also negative because I'm existing, all the coordinates in this section have a negative x and a negative y. All right. So let's just, all right, so that is my theta. Now again, I drop a perpendicular onto the x-axis, right? And then when I label my values, right? So what is this? This is negative x, this is negative y, and r is still always r, okay? And then I guess one other thing that we can discuss here, right? So again, like theta is this whole swing, but I have this angle in there, right? Which is my related acute, all right? So now again, when I write out my ratios, I can say, okay, in this quadrant, right? Sine theta, well, what was sine? Sine was y over r, but in this quadrant, y is negative, so negative y over r. Cos of theta is negative x over r. And then tan of theta is negative y over negative x, which actually the two negatives cancel each other out. So these are my ratios in quadrant 3. So if you notice, right, in this quadrant, which ratio is positive? The tangent is positive. So again, just to reiterate, right, in this quadrant, oops, sorry, let me just undo that. In this quadrant, sine is positive. In this quadrant 1, all of them are positive. And then obviously in the next quadrant, you'd imagine that it's going to be cosine. So let's just do that one. And again, if you understand everything and you feel really good and your self-esteem is running high, then you can just stop this video. All right. So let me just draw my XY grid. How's everyone doing, by the way? Everyone's like just enjoying life? Anyone getting cabin fever yet? It is definitely weird not doing anything for like a month, but you know, we got to do what we got to do. So again, I'm going to have a point here. So now this point, so the x value is now positive because all the x values in this quadrant are positive, but the y is negative. Okay. So again, theta starts at 0 and spins into that section. And then if I drop a height, sorry, I hit the dotted line, right? And then I know, so this value, right, that's negative y, this is x, this is r. And then again, remember, like this angle in here is my related acute, all right? So now same deal, when I write out my ratios, I say, okay, so what's sine of theta? Well, in this quadrant, okay, theta is going to be, or sorry, sine is going to be opposite over hypotenuse, so negative y over r. Cos of theta is going to be adjacent over hypotenuse. Right, now notice the adjacent is positive, so x over r. And then tan of theta is going to be negative y over x. So these are my ratios. And then again, which one is positive? Well, in this section, the cosine is positive. Okay, so pretty much all the questions generally either give you a point that puts you on the grid somewhere, and you just got to be able to figure out, like, you have to be able to draw your triangle properly, and then put it in the correct quadrant, and then use your calculator to figure out what the angle is. Okay. So again, so just a reminder in terms of like, so here, if I have my, right, so again, in this quadrant, all of my ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cosine is positive. All right. And then just remember here, like in quadrant 1, right, theta is going to be what my related acute angle is, because obviously any swing in quadrant 1 is going to be acute. In quadrant 2, theta is going to be 180 minus beta. Okay. In quadrant 3, my theta is going to be 180 plus beta. And then in quadrant 4, my theta is going to be 360 minus my related acute. Okay. Now again, hopefully, as you've done some of the work, you've noticed that the calculator kind of may give you weird answers depending on what quadrant you're in. But again, your calculator doesn't know what quadrant you're in. You do. So this is one of the parts where like human beings are smarter than our calculators because we have a conscience, I suppose. So yeah, so hopefully this video was beneficial to someone out there. If not, I apologize for wasting your time. And maybe I'll post a couple where I will be kind of doing what I was just doing now in different quadrants, just so people hopefully have a better understanding if you have trouble. And again, if you got specific questions, then don't be afraid to ask. All right, later.